In this video, I will walk you through how to analyze histograms. We will be looking at how to read histograms, the information that you can find from them, and questions that you might be asked about histograms. Here's an example of some questions that you might be asked. Here is a histogram, and here are some questions that you could be asked about the histogram. So first of all, how many kids were surveyed? So what this means is just how many kids are there total. So I'm going to look in each of these groups to figure out how many kids there are in each group. So for example, between 0 and 10, there's 1 kid. Between 10 and 20, there are 6. Between 20 and 30, there's 9. Between 30 and 40, I have 8, and between 40 and 50, there are 3. So then to figure out the total, I just figure out, well, all together, in all of these groups, how many are there? So let's add them up. 1 plus 6 plus 9 plus 8 plus 3. I'm going to make my groups 10. Then I have 6 plus 8, 14 plus 3, 17. So I'm left with 10 plus 17 is 27. So altogether there are 27 kids in this graph, or 27 kids surveyed. So my next question is, how many kids watched at least 30 minutes of TV? Yes, you may have noticed I changed this. I wanted to change the question slightly. So now we have at least 30 minutes of TV. So I need to think about, what does at least mean? If I say at least 30, can it be less than 30? No. Can it be more than 30? Yes. At least 30. Could it be exactly 30? Yeah. So at least 30 means 30 or anything bigger. So that's going to be any of these bars right there. So how many kids watched at least 30? Well, in this bar I have 8, and in this bar I have 3. So 8 and 3 together is 11. 11 kids watched at least 30 minutes of TV. Then the last question, how many kids watched exactly 30 minutes of TV? So in a histogram, can I tell exactly how much TV every single kid watched? No, I can't tell the exact numbers. I know there's 9 kids who watched between 20 and 30, but I don't know if they watched 20, 21, 28, 29. I don't know the exact numbers. So do I know how many watched exactly 30? No, I don't know. So then here I would just say I cannot tell from the graph. If I had a table that went with it, then I could look at that and see the numbers, but I don't have any numbers that go with this. It's just the graph. So with the information I have here, with just this, I can't tell. So that's an okay answer for this question. So now it's your turn to try this on your own. Here's a new histogram. It's this time though about time to shower, so how long it takes people to shower. So here, what are we measuring? The time in minutes. And what are we counting? The number of people. So how many people take between 0 and 5 minutes? 2. How many people between 5 and 10 minutes? 6. And so on. So you're going to answer these 3 questions. When you are done, so you'll pause the video, and when you're done answering these 3, play it again to check your answers. Here are the answers that you should have gotten. So how many people were surveyed? Well, I counted up how many there were in each group, and then I added it all up, and in the end you should get 38 people total. How many people took less than 10 minutes to shower? So less than 10. So less than 10 is going to be anything over here. So here is less than 10, and here is less than 10. So I have 2 and 6. Altogether, that is 8. Then how many people took exactly 15 minutes to shower? Well, like we said earlier, you cannot tell exact amounts on a histogram. So we don't know exactly 15 minutes how many people it took to shower exactly 15 minutes. So you would say you cannot tell from the graph. We have now 2 different shapes that a histogram could be. So one of the general shapes that it could be would be this. We have a special name for this kind of graph. It is called a bell-shaped curve. So this shape here, if you think, for example, like Mexican Independence Day, they ring the bell, it looks a lot like a bell. So in math, we really do call it a bell-shaped curve. Now these graphs, where we have a lot on one side and not very much on the other, we have a lot on this side, not very much on the other, this special name is called skewed. A way to remember this would be like a person who has really strong opinions. They favor one way over the other, just like here. Favors this side over the other, this side over the other. A person with skewed opinions, they think one way, one side, and not the other side. So just like this graph here. Then the next step would be to draw a line approximately where the mean would be. So we don't know exactly where the mean is. We don't have the exact numbers here, but we can guess where the mean would be based on the shape. So mean is all about what would we typically expect. So looking at these graphs here, where would we typically expect to see a response? So where is it really common? So for example, on this first one, there are a lot right here in the middle. So our mean is going to be about right there. That's typically what we would expect. Now down here, it's a little bit different. So when I'm thinking, where do I have a lot of? Right here. So I would draw the line there, except that's not quite how it works in a skewed graph. So a skewed graph, just like a person who has skewed opinions, they like one way over the other. It's mean. A skewed graph is mean. It brings down, it pulls the mean towards it. These little ones down here, they're strong, but they're powerful. They pull the mean towards it in this direction. So instead of going, let me erase this line here. Instead of going there, the mean is going to be pulled down about right there. Same over on this graph over here. It's not going to be over here. These little ones here, they're mean. They're going to pull the mean over this way. So my mean would be about right there. So for a little extra practice, see if you can answer these questions about these graphs. So try not to peek at what we just did right before this. See if you can remember. For this graph here, what's the shape that we call it? And then where would I draw the line? Where would I draw the line to show about where the mean would be? You do the same down here. What's the special name I call this shape? Then where would I draw that line to show where about the mean would be? So pause the video, and then when you think you have it, you can play it again. So this is what you should have. This first one, the special shape, it's called a bell-shaped curve, and the mean would be about right here in the middle. On this one, the special name we call this is skewed, and these little ones down here pull down the mean, so our mean would be about right there. The last topic about analyzing histograms that we will talk about is persuasive graphs. So persuasive meaning trying to convince. So these graphs are trying to convince you of something. So for example, looking at this graph, a person might say that the amount of time that you're spending in the shower, it's increasing so much that now you are taking, so here's the number of days, triple the number of days on longer shower times than you were at the beginning. So saying like this is triple the amount that you started at. So the question for you is that true? Did the number of days really triple? So you're going to think yes or no, and then explain why. Why or why not do you know that if it tripled? So hopefully you figured out that no, it didn't, this is not triple this. And so now we need to think why. How do we know that it's not tripled? Well, I can look over here at these numbers. Here, between 0 and 5, 5 and 10, I spent 51 days taking showers for that long. Then over here, between 30 and 35, 20 and 25, I spent 55 days taking showers that long. So is 55 triple of 51? No. So I know that even though it looks a lot bigger, it's really not triple. If I look at the numbers, I can see, no, 55 is not triple of 51. So you might have thought of an explanation, something like this. No, and how do I know? 55 is not 51 tripled. I need to read the numbers on the graph. So if I actually read the numbers that these bars are at, I can see, nope, it really did not triple. So when you are asked questions about graphs, especially graphs like this that might be persuasive, it's really important that you are reading the numbers along here to figure out if they're trying to trick you, if they're trying to convince you of something. And this is the end of this video of how to analyze histograms. Hopefully you have a little better of an understanding now and you feel a little bit more confident with this.